So this video, we want to find the derivative of y equal to 2 raised to the x power. So this is an exponential. We've flopped around. It's no longer x squared. Taking the derivative, that's easy. I just used the power rule, bring the 2 out front, subtract 1 from the exponent. So it's a little bit different when we swap the roles of the variable and the number. So what do we know? Well, we know the derivative of e to the x is easy. It's e to the x, right? So we know that to be true. So what else do we know? We also know I can take 2 and raise it to, and then do, so if I take 2 and I do the natural log of it, that changes it. But if I do e to the natural log, the e to the natural log undo each other. Okay, so this is equal to 2 still. So that's a clever way to write 2, all right? And so what does that tell me? Well, if this is equal to 2, then 2 raised to the x power is equal to e to the ln 2 raised to x. Now, when I have a power to a power, I multiply, and so I have e raised to the x times ln 2. So this, my friends, is the same thing as this right here. And why is this important? Because look, we know the derivative of e to the x is e to the x, right? So now we have e to the stuff, and we can apply the chain rule. So the derivative of e to the stuff is e to the stuff times what? Was the stuff, the derivative of the stuff here. So the derivative of x ln 2. Now you got to remember, ln 2, that's just a number. That's like 0.69 something, right? I don't, whatever. But that is only a constant. So that would be a constant multiplied by x, which is derivative is really easy. All right, so what is this equal to? This is equal to e to the x ln 2, because remember the stuff here is x ln 2, okay? And then the derivative of x ln 2, well, the constant stays the same. Derivative of x is just 1, so that's where the ln 2 comes into play. All right, now, what do we know here that we can use to simplify? Well, we know that this right here can be rewritten as e to the ln 2 raised to the x here. And what do we know that e to the ln 2 is equal to? That's equal to 2. So this is the same thing as saying 2 to the x, okay? That's 2 to the x. So the derivative of 2 to the x is 2 to the x multiplied by ln 2, all right? So that's for the derivative of 2 to the x. Is there some pattern in general? So in general, what's happening here? Well, if I had the derivative of some a to the x, okay, so some a to the x function where a is positive and not equal to 1, then f is differentiable. So a to the x is differentiable for all real numbers, and the derivative of this is equal to a to the x times the natural log of a. All right? So that is the in general, where a is any positive number. So a is, between 0 and infinity. Okay? So any positive real number. So if a is a positive real number, that's what we mean by that little symbol right there, a positive real number. All right.